Assalamualaikum and hi everyone. Today we are going to learn about the symmetric test. So if you refer to your module, you may turn to page 95. Okay, so this is the theorem of symmetric test. And basically we have three types of symmetric tests. Whether we can test the curve is symmetric about x-axis, y-axis, and also symmetric about the pole. Okay. So let me explain to you the details. A curve. Okay, let me change the color. A curve r equals to f theta is number one, symmetric about x-axis if we can show that f theta equals to f negative theta. Okay, so this is the formula to show the curve symmetric about y-axis. Okay, physically it's something looks like this. Let's say this is your x-axis and here is your y-axis. So for example, let's say we have this coordinate here with r and theta. So let's say this is theta. Then if this coordinate can be reflected here, okay, so r negative theta, we can say that the curve is symmetric about x-axis. Or in other words means that if you fold your paper towards x-axis, then this point reflected below here. Okay, so that is the first case. Second case, we can show that the curve is symmetric about y-axis if we can show that f theta equals to f pi minus theta. So this is the formula to test whether the curve is symmetric about y-axis. Okay, physically, the graph will be like this. Okay, so this is x-axis and this is y-axis. So let's say originally we have a point here with coordinate r theta. We can say that the curve is symmetric about y-axis if we fold the paper towards y-axis. Then we have this point reflected here. Okay, so if we can show that this point can be reflected on y-axis, we have pi minus theta. So yes, we can say that the curve is symmetric about y-axis. So this is the angle theta, and this is the angle for pi minus theta. Number 3. A curve is said to be symmetric about the pole if we have or if we can show that f theta equals to f pi plus theta. Okay, so this is the formula. Or physically, something looks like this. It is the same like if we want to sketch or plot for the case of negative radius, okay, where we have here x, y. Let's say this is the original point of r theta. Okay, and then the reflection is here. So we can say that, we can say that the curve is symmetric about the pole. This coordinate is r and pi plus theta. Or this is, if you remember, plotting the polar coordinate, this is also equivalent to negative r theta. Okay. So now this is the angle of theta, and this is the angle for theta plus pi, or pi plus theta. Okay, so let us do some examples on symmetric tests. Example 1. Show that r equals to 4 cos theta is symmetric about x-axis. So solution. Okay guys, if you refer to the previous notes, we know that in order to show the curve is symmetric about x-axis, we need to show that f theta equals to f negative theta. So first of all, we let f theta equals to 4 cos theta. And then we need to find f negative theta. So we substitute theta with negative theta. Then we have f cos 4 cos negative theta, like this. So basically, if you use your calculator now, okay, if you calculate cos negative pi, you will get the same value as cos pi, right? And then if you calculate cos, let's say negative 2 pi, you will get the same value as cos 2 pi. Am I right? Okay, so now, since cos theta is equivalent to cos negative theta, so we can write this as 4 cos theta. Okay, so if you notice here, this is the same as f theta. So yes, equals to f theta. So yes, it is symmetric since f theta equals to f negative theta. Thus, it is symmetric about x-axis. Shown. Graphically, if you want to you want to sketch the graph. Okay, let's say we sketch r equals to 4 cos theta. So we have graph of cos here. We know that cos is symmetric to x-axis. Therefore, the graph will be like this. X and y. Okay, this is 4. So we know that the point here, if I can, okay, we know that the point here should be reflected to this point. Or in other words, we can say that the curve here can be reflected to this area. Okay? So yes, 4 cos theta is symmetric about x-axis. Okay, done. Let us do next example. Example 2. Show that r equals to 3 plus 3 sine theta is symmetric about y-axis. Okay, so solution. So let us scroll the notes. Okay, this is the formula that we can use to show the curve is symmetric about y-axis, where f theta equals to f pi minus theta. Okay, so let us answer the question. First, we let f theta equals to 3 plus 3 sine theta. Okay, next, we need to find f pi minus theta. So we substitute pi minus theta in theta here. So we have 3 plus 3 sine pi minus theta. Okay, now we need to use the trigonometric formula. So trigo formula here said that if we have sine a minus b, this is equals to sine a cos b minus cos a sine b. So let's say pi is our a and theta is our b. Okay, so now we can substitute the trigonometric formula. We will have 3 plus 3 sine a cos b, so sine pi cos theta minus cos a sine b, so cos pi sine theta, like this. Okay, we know that sine pi is 0 and then cos pi is equals to negative 1. So we will have 3 plus 3, 0 minus negative 1 times sine theta. So we will have 3, negative become positive, right? So we have 3 plus 3 sine theta. So yes, from here we can show that this is equals to f theta. So the conclusion is, since f theta is equivalent to f pi minus theta, thus it is symmetric about y-axis. Okay, let me show you the symmetric test using graph. Okay, so if we let us sketch r equals to 3 plus 3 sine theta. So this is actually a cardioid, right? We have a cardioid here. So if we plot the graph, we know that we have sine here. So of course it's related to y-axis. X and y-axis. So the graph will be like this. Okay. So now guys, this coordinate here should be 3 and here should be negative 3. So of course, obviously we can see that from this graph, r equals to 3 plus 3 sin theta is symmetric about y-axis because this curve is symmetric to y-axis here. Okay, if you fold your paper towards y-axis, then you can see that the line reflected to y-axis. Okay, done. That's it. All right, next example number 3. Show that r equals to, let's say, 7 cos 2 theta is symmetric about the pole. Solution. Okay, let us scroll down. Symmetric about the pole. We need to show that. Let us scroll back to the formula. Yes, here. Symmetric about the pole if f theta equals to f pi plus theta. Okay, f pi plus theta. So now let us answer. First of all, we let f theta equals to 7 cos 2 theta. Next, we need to find f pi plus theta equals to 7 cos 2 pi plus theta. Or we can write this as f equals to 7 cos 2 pi plus 2 theta, right? Multiply 2 here. Okay, now again we need to use the trigonometric formula. Use trigo formula. Okay, now we have cos. So cos A plus B is equals to cos A cos B minus sin A sin B. So in this case, 2 pi is our A and then 2 theta is B. So we have 7 cos A cos B. So cos 2 pi cos 2 theta minus sin 2 pi sin 2 theta. Okay, cos 2 pi is actually equals to 1. Sin 2 pi is 0. So we will have 7 cos 2 theta minus 0. So finally we get 7 cos 2 theta. And this is actually f theta, right? So we can conclude that since f theta equals to f pi plus theta, thus it is symmetric about the pole. Okay, so let us plot. If we sketch the graph, seven cos 2 theta. This is actually a rose curve, right? Rose curve. we have n equals to 2, so means that we have 4 petals, right? So the graph will be like this. One, two, three, 4. And the value here is should be 7, 7, -7. Here is -7. Okay, in fact guys, r equals to 7 cos 2 theta is special because it's not only symmetric about the pole, but it's also symmetric about y-axis and also symmetric about x-axis. Okay, so that's it. That's all for today. Hope you understand the symmetric test. Good luck.